Welcome, Chris, to the IoT For All Podcast. Thanks for being here this week.
Hi, Ryan. Thanks for having me.
Absolutely. Yeah, it's great to have you. Excited to have this conversation. And we're going to touch on not just IoT AI, but also computer vision, which is a very exciting topic. But I'd love it to maybe kick things off by just telling the audience a little bit more about yourself, the company, what you all do, just at a high level.
Great. Awesome. So my name is Chris Ricciuti. I am currently founder and CEO of a startup called Noteworthy AI. What we do is make a vehicle mounted camera and artificial intelligence system that helps electric utilities, the folks that keep our power on, ensure that the electric grid is reliable, resilient, and safe. So with our technology, we basically mount on a variety of different vehicles, everything from a pickup truck to a heavy duty bucket truck that you might see, driving around your neighborhood. And whenever those vehicles are out in the field, we're automatically with computer vision identifying certain conditions that the utilities need to address. So, for example, poles that are leaning excessively, damage on pole top components, things like that. In terms of me, myself, I guess you could say a serial entrepreneur at this point. I've done a few startups focused on enterprise technology for large enterprises.
Throughout your career, how have you seen kind of the evolution of computer vision compared to where it is now, maybe where it was a few years ago? It seems like it's a rapidly growing, maturing, improving, a technology that is really starting to dominate a lot of solutions and becoming more widely used by organizations.
Yeah, I mean, I think the main thing that changed over the years is the cost of compute has gone down significantly, kind of dovetailed with the availability of data. So, it's funny that a lot of the algorithms that are employed today for computer vision or other AI ML were formed in the 60s, right, or in the 50s. So they've been around forever. It's just you couldn't really practically apply them until the cost of compute came down and the data became available. So those two things, the confluence of those two things have led to rapid development, I would say, particularly the progress in recent years. And then, kind of beyond that, it's all about finding practical, real world use cases where there's a quantifiable return on investment, right? There's quantifiable value proposition. And that certainly, generates interest in the technology further.
Yeah, it's very similar to what we've seen just with the growth of the IoT industry, and as we're seeing in real time, the growth of the AI industry. The technologies are fantastic. Even just it's a standalone. People can talk about all the different use cases that they're applicable for, how they can be put together with other technologies. But until you find a actual business solution that you can solve that provides real value, real ROI, the technology, I don't want to say is limited, but in its kind of potential, it kind of is, right? If you find a way to use the technology to solve a real business problem, we're not sure where it's going to go. My assumption would be prior to the technology being mature enough to mount these cameras on vehicles to drive around, I imagine most of this was a manual process for checking, like driving around and using your eyes. That's kind of the way at least I would envision this was done prior to the technology being created.
Yeah, and you would be correct. As manual as you could imagine is the way it's been done for probably the past 100 years, right? Since the advent of the grid, and before perhaps. But effectively, yes, the way these, let's call them grid assessments or grid evaluations, were performed historically is sending out quote unquote boots on the ground, people walking around, driving around, a number of people in the vehicle, for example, a driver and a passenger. A passenger has binoculars and is kind of looking up for problems. And that's not to fault the utilities or the people that are doing that work. That worked, for a long time, right? It was providing value. It was a way to evaluate assets in a different environment, right? When there weren't so many demands and risks on the grid. But fast forward to the future, things have changed. The paradigm has shifted. There are a lot more risks and threats to the grid that we could talk about, which require a much more scalable, cost-effective way to go out and perform these evaluations.
And I want to dive into that here in a second. But maybe prior to doing that, if you could just set the stage here a little bit for our audience's benefit, what are the biggest challenges that these utility companies face when trying to maintain grid reliability, right? And then that kind of ties into then how you're using the technology to change the game for them, which we've kind of touched on. But being able to understand really what the technology is enabling a company to do that a human can't do, besides just the scale. But obviously someone still has to drive the car, so there's still some requirement of the people. I would love if you can kind of connect those dots from the challenges through to what the technology is enabling organizations to do that humans were not able to do just by themselves.
For challenges and risks to the grid, I think we've all seen the headlines at this point. There are quite a few of them. And first and foremost is the increased occurrence of extreme weather events. So, be it more frequent hurricanes in the southeast, stronger hurricanes. There were a couple earlier this year that we actually deployed for in the context of helping. To wildfires out west, extreme drought-like conditions combined with utility grid infrastructure that, could potentially trigger a wildfire. So there are a new set of challenges as it relates to extreme weather that utilities need to mitigate. Similarly, demand is actually a challenge, increased demand. So rapid adoption of electric vehicles. People don't necessarily think about it, but the solar panels that you're putting on your roof, especially if you're doing what's called net metering, selling your power back to the utility to get a credit, right? Or for them to pay for your basically the generation capacity that you've created with your solar panels, that requires bidirectional power flow on the grid. Historically, the grid is unidirectional, right? From the plant to your house. So components need to be upgraded, investments need to happen in order to support that bidirectional flow. And this all kind of comes at a time when infrastructure, particularly infrastructure in the United States, is old and rapidly aging. So if you look outside your window and you look at a utility pole, the average age in the United States of one of those is anywhere from 40 to 50 years old in the United States, which is definitely the tail end of its usable life. So it's kind of this perfect storm of events and risks that are all coming together to make the old way of kind of managing and evaluating the grid not tenable anymore. The last point I'll make on this is the other headline that you've probably seen a lot of lately: AI data centers, like where we're going to get the capacity to power all these data centers. Same story. If we're going to increase our capacity by, I think the current plan is to double our output, our power output by 2050. Guess what? The poles and wires need to get upgraded as well. So how do utilities make informed decisions about where to make those upgrades precisely on a per pole basis, right? That's the challenge. So as it relates to our technology and to your point about doing things that humans couldn't do before, the main benefit is actually it's twofold. It's scale, it is scale, and it's automation. So, I explained before how the status quo is binoculars and notepads driving around, very, very labor intensive, right? And because it's very labor intensive, it's very costly. That means historically it doesn't scale. So if you're the average large utility in the United States, you have quote unquote eyes on, you're evaluating about 10% of your grid a year. Some cases it's 15, some cases it's less than 10, but that's it. So you're on a 10-year cycle to go out and evaluate your full grid. You have little to no situational awareness, right? So that's the first thing that our technology enables. The way that we install, not to get too into the weeds on this, but the way that our camera systems install and the fact that they work fully autonomously, leveraging the trucks that utilities are already driving for other purposes to go service a customer, replace. Right. They're going to be out there anyways. It works during routine operations. That means that we can get a much greater scale. And then through the automation side of it, right, through identifying and flagging these issues in an automated way, instead of crews being dedicated to finding the needle in the haystack with binoculars out in the field, the AI is doing that filtering for them. And it's surfacing the needle in the haystack, the relevant subset of results that you need to go address now. And so the automation enables a shift from kind of this, mundane work of going out into the field and finding problems to actually going out and fixing them because the AI is finding the problems for you at scale.
So it also eliminates some level of human error on missing things. You hope that they're trained well to know what they're looking for, but at times they could miss things. And if you train the model well enough for the camera, should be able to pick up things on a pretty consistent basis. And I guess which ties into a question I'm just curious about is how you have trained the models, given that the environment and the poles and everything in out in the real world is different. The trees that surround a pole are different. The poles themselves are different. Just the conditions are always varying, weather, et cetera. How's that play a role, or how have you kind of combated that to ensure the accuracy?
So to first address your first point about, let's call it the accuracy of humans and the fact that they miss things. Sure, no one's perfect, right? You could argue that humans are pretty accurate at, hey, there's a problem on a pole. I'm driving down the road, I'm trained to see it. But inevitably, no one's at 100%, the AI nor the people. But I will tell you that if you're looking at 10% of the grid currently, right, each year, for the other 90%, you have 0% accuracy currently with the status quo. You have 0% because you're not looking at all. right? So again, the value of this scale, not just the accuracy of the AI, and the AI, which ties into your second point, is always getting better and is already a really good level of accuracy in terms of identifying certain defects and things like that. So really valuable. But to your point about environmental conditions and training, that is definitely a challenge. And we've been fortunate enough to be working with major utilities at this point throughout the globe. So it gives us the opportunity to collect data across an array of environmental conditions and variable conditions. So certain parts of the world, certain times of the day. The sun is, high noon. The sun's behind the camera, in front of the camera. It's overcast. It's raining. It's snowing. The vehicle is also moving variable rates of speed. So in some cases, it's moving very fast, very slow. It might be in the left lane, the right lane. All of these things matter when it comes to training the AI. But specific to the poles and the equipment, like transformers around poles, those also look different in different geographies, right? A transformer, while it's wholly the same, it's a cylindrical object that's on a pole, might look different in Florida, for example, than it does in New Zealand, right? So what the broad deployment over the years has done for us is given us the opportunity to get all these data samples and funnel that into iterative model training to make it generalize really well for any type of condition or any type of pole composition, as we call it.
Can you tell us or take us through maybe a quick real world example of where your solution kind of helped utilities reduce outages or improve reliability, things like that? I do want to kind of like expand from there into the more extreme conditions when it comes to weather. And you talked about storm impact assessment and things along those lines. But let's start off kind of just from a basic standpoint when it comes to reducing outages, improving reliability. Any example you can kind of throw out for our audience?
Yeah, for sure. So I'll leave the storm response to future because that is a big one that I want to touch on as well. For example, there was a utility in the Midwest that part of their, let's call it, service territory, their area, geographic area that they service, was known to have very bad reliability scores, right? These are metrics that utilities and the public and the media track, right? To see how well the utility is performing, what percentage of the time is the grid going out. So the utility wanted to go and make some investments into improving the reliability scores in that particular region. And the first step in improving your reliability score is you have to know what needs to be fixed. And therein lies the challenge. Back to the original point with the binoculars and the notepads, not doing it at scale, doing it at a really high cost. You need to know precisely what needs to be fixed in order to improve reliability. So we were deployed in that capacity in the Midwest over a 3-month period to go out and evaluate that portion of the grid and flag certain reliability defects, as a utility would call them, that if left untreated could lead to an outage and therefore adversely impact their reliability scores. So it's preventative maintenance, but in this case, it was in an area that was known to have really abysmal reliability. So some examples of conditions that we found were poles that were severely deteriorating. So poles are often wood. In some cases, they're concrete and steel, but predominantly in the United States, they're wood. Wood degrades over time. It's 50 years old, the wood, right? It's treated, but falls apart over time. Similarly, if you ever look at a utility pole, the cross arms on the top, the T shape, those degrade to the point where basically the wire is about to fall off the pole. And unless you get up in front of it and proactively address it, you will have an outage and even worse, potentially a safety issue. So we were deployed at scale and we were measured on our ability to flag these defects quickly. And there's also a cost effective element to this as well, very cost effectively compared to the past.
Yeah, so let's dive into the more extreme kind of weather situation about storm impact assessment, things like that. How do you all help utilities basically respond faster to issues and just be more effective during these severe weather events? So, any example or just kind of talking about what that dynamic looks like would be kind of cool to hear.
Let me describe what happens when major storm like a hurricane comes through. If a large hurricane, for example, there's two of them this year that are they're of note, Helene and Milton. They both hit the eastern part of the United States, square on in Florida, but then all the way up to North Carolina. You probably saw the headlines. The damage was pretty severe. And whenever there's an outage caused by a storm such as Helene or Milton, The utilities that manage the grid are responsible for bringing power back online. They're under immediate and intense pressure to restore the grid. And the first step in restoring the grid, restoring power to the grid, is performing what they call an ETR, an estimated time of restoration. So, how long am I, Joe Smith at 1223 Main Street, going to be without power? Is it going to be a week? Is it going to be a day? Is it going to be 2 weeks, right? So I can plan accordingly. And in order for the utility to provide an accurate being the key word here, estimated time of restoration, guess what they need to know first, right? They need to know where the damage is. And again, this isn't broad stroke, okay, this area is out. They already know that, like this region is without power. They need to know on a per pole basis where the damage is, what type of damage it is, go cut tickets like work orders for their crews to go out and pull new transformers, new poles out of inventory, and then physically go there and reinstall them. So it's a big process, right? And step one is doing an accurate damage assessment as quickly as possible, which enables both accurate estimated times of restoration and ultimately power restoration, the actual restoration itself. So if you look at historically the way these assessments are performed, same story, right? It's very manual, labor intensive, binoculars and notepads. On average, for a utility to get, for example, from a set of poles or even a single pole, to get those assessment results, because the whole process is manual, back into the command center to go ahead and say, okay, we need this number of transformers, this number of poles, let's mobilize a crew to go replace it. On average, it takes 24 hours to get those results, right? So it's a long time. There's a long lag. In some extreme cases, it's 48 hours. With a technology like ours, enabled by IoT and real-time AI in the edge for these storm-specific damages that we've developed computer vision models for, we can send the results up to the command center in minutes on a per pole basis. So you could see the value not just in, okay, now we know precisely what the damage is, and therefore we can actually provide an accurate estimated time of restoration, but we can also much faster go pull that material from inventory and much faster mobilize a crew to get out there and fix the problem and restore the power. So it's very impactful and very valuable.
That's super impressive. Like this whole solution, I think I've been pretty enamored recently with just computer vision and what cameras are actually capable of doing, and thinking about it in the way of like, look, if you have a process or something that right now you're using a human to be able to look at, see, and assess, there's almost no reason why you couldn't replace that with a camera, train it, and have it become more sophisticated over time to do exactly what you're doing across any industry, right? Or and many different problems, which is super fascinating. Our audience is obviously a mixture of people from many different industries, but speaking specifically to utilities and that kind of world, why is now the time for those types of companies to really start to look into and adopt AI, this vision, IoT solutions, especially with, you talked about it already, aging infrastructure, extreme weather conditions around the country. Just why is now the time that they really can't, delay this any further?
Yeah, I mean, it's for the reasons we talked about. It's the triple threat of reliability, resiliency, and safety. And the fact that these risks to the grid, be it from extreme weather and extreme weather events, or increased demand, or data centers, or aging infrastructure, or a combination of all the three, means that, or all the four, excuse me, means that the what used to work for the past 100 years will not work for the next 100 years. So the time is now, and utilities understand this. And regulators, without going into kind of too much detail about the regulatory structure for electric utilities, they are regulated at the state level. And regulators are beginning to apply the pressure to utilities as well to make sure that they're going to be able to provide the grid of the future. And to do that, you need situational awareness to mitigate against those threats and those risks.
And if we look kind of out into the future, how do you see these technologies, AI technologies, IoT technologies, vision technologies evolving to support the future grid trends that we're seeing, like, larger EV adoption or renewable energy integration, things along those lines? How are these technologies going to continue to play a role as we advance forward?
I think, it's just a function of deploying the cameras in more places, making them more ubiquitous or widely available, and training models, both iteratively on existing computer vision models, and then net new models that do something that computer vision is not doing today. to provide a much more kind of comprehensive kind of blanket solution. So as utilities kind of dip their toes in the water with deploying these technologies, and they're starting to think about scale, more and more use cases come up, more opportunities, if you will, to deploy more cameras for additional things and develop more models for additional use cases.
And I wanted to ask you, so just as we kind of touched on this right when we started about just the evolution of the technologies, if I'm listening to this and I'm a business looking into AI, IoT, vision technologies, different solutions that incorporate these technologies, what's one thing you would tell those organizations? Like, what's one key takeaway or piece of advice you'd share for them kind of getting started on that journey? It doesn't have to be utility focused, just can be for any kind of business.
I would say that don't expect a silver bullet to your problem, whatever the business problem is. AI is not the end all be all for everything, at least not yet. It's on its track, or it's on the track to do that. Will require continued investment, but have realistic expectations going into it. Start with a small subset of your problems, and focus on applying technology in a very defined way with a very quantifiable end goal and value proposition, and then scale it from there. But the key is not to have unrealistic expectations. It will certainly take some turning of the screws to get it exactly where it needs to be, but it can get there.
Thank you so much, Chris, for your time. This has been an awesome conversation. I love being able to take technology, talk about technologies being applied in the real world to solve real problems. Sometimes we get super high level and we're just talking about general technology that, what it can and potentially could do, but this is actually real world stuff. So this has been awesome. For our audience who wants to learn more, kind of dive in further, maybe follow up with any questions, what's the best way they can do that?
They could go to our website. We've got contact forms they could fill out if they want to reach us. It's www.noteworthy.ai. We're here to help keep your power on, ensure the grid is there. So we're increasingly being deployed by large utilities throughout the country. And the goal, again, is to help improve reliability for all of us. So expect more from us in that regard.
Again, appreciate the time. Excited to get this out to our audience. Yeah, we'll hopefully talk again soon.
Awesome, Ryan. Thank you.